Welcome back to educator.com Intermediate C++. Today we'll be talking about macros, a little bit about compilations, and this, believe it or not, is an ampersand. Fancy font. Whee! Okay, so we have preprocessor macros. This is another feature from C, and if you use it properly, it's an extremely useful feature in C++. You've already seen that. You've seen the pound include directive that retrieves other files, particularly header files, brings them in your files, and you might think, oh, that's a C++ thing. No, well, it's a C thing. No, it's a C preprocessor thing. When you see the pound sign in the first character of the line, and then a directive after that, then that is a preprocessor. The C++ compiler, with few exceptions, never sees any code like this. So one of the directives is define, which is used to set constants, and it's one of the things that was a very common way of setting things in C, where you'd have a list of variables. Pi equals 3.14, so you'd have a define, you'd have pi, you'd have 3.14 or 15 or whatever you wanted it to be, and then you'd have all your various constants would be defined this way. Now in C++ you would use a constant instead, because that way you get a type. You'd say const double, and then pi, and equals whatever it's equal to. So it's usually better in most cases with many of the macros that are available to you. You're better off to use a C++ language feature. There are occasions when you can't, but when you can, you should use them. We have conditional compilation that can make huge sections of code just completely disappear. The compiler will never see them, basically because the preprocessor will remove them before giving them to the compiler. And we'll also cover a little bit of command line compiling, where you can put different options on the command line when you compile your code. Particularly, it's important stuff. You can pass in a macro on the command line, which you can then process with the preprocessor to, for example, take entire sections of code and make them go away. So we'll have flags that allow the compiler to find files that it can use to compile with, which, for example, to get an include directive. When you say include, you need to tell the compiler, where am I going to get that file to be included into this file? And we can facilitate debugging, where we can print out certain information and set values for the preprocessor macros. So, like I say, it's another feature left over from C. It has some of the same dangers that it had with C. Those dangers are still there. C++ has replaced many of those dangers with a language safe feature, but some areas are still dependent on the preprocessor macros. You define it by having a pound or a hash sign or whatever you want to call it, checkerboard, I've heard it said, hash mark in the first column, followed by your macro keyword, whatever it is, define, if, def, etc., followed by the macro name, if there is one that goes with it, and then its definition. The definition goes from there. When you have a define, it goes from the define keyword to the end of the line, which we'll talk about more later because it's very important. The macros are pre-processed on a textual basis. The C++ compiler has no idea about the type of what's being going with. That's where your dangers come in. And there's no regard to the C++ language, C or C++. You can do all, because it's a text replacement. You say define this to be that. So everywhere inside the code where this shows up, the preprocessor says, wow, that's one of my things that were defined. You throw that out and put the replacement there instead. So the compiler has absolutely no way to check for types, syntax, ranges, anything else that you would want the compiler to test for you. When you use a preprocessor macro, you throw all of that out the window. You throw it out the window with caution, with care. Now, like I said, many legacy uses, you don't need the macro anymore. You don't need to use define to make a pi, to make it equal to a certain number. You can now use a language feature, constant, and that way you can give it a type and set it equal to what. And this is important because you may not need a double, for example. You may only need it to be float, and the compiler might upgrade it, might promote it to a double. Anyhow, the compiler can do type checking if you use the C++ features instead of the preprocessor macros. So anytime you need a precompiled library, and you have to include the include file, the header file for that, you use the include macro. So IOStream is a header. It's actual text header. You can go on your system, you can look it up, you can find it, you can actually read what's in the IOStream header. You can write your own header. And if you've been paying attention in the object-oriented classes, you've seen where we have created a header file which made the definitions for our various class prototypes. And then someone who's going to call your code will include your header. And they can read your header, but they cannot read the algorithms that were compiled into binary form. Now, the triangle brackets traditionally mean the include file will be found in one of the preprocessor's known locations, or you can specify it to the compiler on the command line. The quotes indicate that the include file is probably located in the same directory as the source file. If you could designate a path with the dots and slashes, and so it will start in the current directory. The dot means go up a directory, and then go down to the other directory, and then your particular header file. Now, any text file can be included. And what I have seen some people do, and you really should not do this, is they'll actually include a C source file or a C++ source file using the include directive. So, for example, they might put together a function. So this would be my function, and it'll do whatever it's going to do, and they'll put that into a C++ file. And the program that uses that will include this C++ file. Well, yeah, you can do that, but it's really not a good idea. It's a better idea to define the header. See what I'm running out of room here. So you just have your prototype for your function. Define what its return is, and then put that into a header file, which would be H or HPP, and then include that. And then at link time, you compile your CPP or your C program, compile it separately into an object file, and then link to that. So now other people can read the header file, they can't read the object file, and it's only compiled once. If it's included into various separate files, among other problems is that it can be compiled more than once. The compiler may detect that that name has been used already, won't let you use it again. So for a number of reasons, yeah, you can include a CPP or a C file. Don't, please, don't. Use the header files. Now here's your basic constant definition. You've got define, max rows is 300. You can still use that. You can still do it that way. You don't need to use the C++ language convention. You're probably better off with C++, but just to know that this is there. You will see code like that when you're out in the wild looking at real code. Notice there's no equal sign. What you have is define, and then a word that you define, and then what it will be replaced with. And there's no semicolon. This is not C++. This is not C. This is the preprocessor language. And you can put it anywhere in the code. You could be writing all kinds of code here, then say define max rows is 300, then have some more code after that, which actually makes use of the max rows. Traditionally, you'll put them all at the top, but they don't have to be all at the top. The uppercase is just a convention. So when people are reading the code and they see something that's all uppercase and all, that's a define, that's a macro that's been set somewhere up here, up towards the top of the code, or in some header file someplace. It has been defined to be some constant. So I know that because it's all uppercase. It doesn't have to be all uppercase, but you're probably better off to stick with convention. So what happens is the preprocessor reads the input text. If you type, put into Eclipse or put into your word processor or into Vim, and from this point forward, every time the preprocessor sees the keyword max rows, it throws that out, puts in 300, just like its regular text. It's almost just like the search and replace function in your word processor or your editor. The compiler never sees max rows. It will not be in the text file when the compiler gets it. What the compiler will get is 300. So when you have this code like this, int rows max row, and you have your loop is less than max row. I've used max row without the S more often, so let me erase the S. There we are. So literally, what the compiler will see is int rows. There'll be a 300 there. Same thing here. There will be a 300. If you say define max row Charlie, it will put Charlie here, which may or may not make sense. Maybe you've got a variable out there somewhere where Charlie has been set to be equal to 300. It'll have the same effect. But you have to remember that this is not the compiler doing any work. This is the preprocessor doing the work before the compiler gets it. So you can literally define anything. You can define max string to be 300 in quotes. So you say the max string is max string. So this will print out 300, the words. So a typical use is to have a header file that includes all of your constants that you want global to the entire system. So for example, we've got pi defined to be 3.1415. The PSI is sea level 14.1. Success is 0. The first error is 1. The second error is 2, etc., etc. Using C++, though, you can actually have type defined. The compiler can check the types for you. So you've got pi is equal to that value, the pounds per square inch, and then we have an enum, an enumeration for success, error, and the second error. Now, I don't know if there's any convention at this time to make these uppercase or lowercase, so I just use them lowercase because I think that looks better. But you might want to make these uppercase like the old defines were. The only problem, of course, being that when someone's reading your code, they might want to go looking for a define, and instead they've got your C++ const. So yeah, I'll let you worry about that problem. Now, of course, you can use macros in macros. Like we've got max rows is defined to be 100, size is defined to be 50, and we've defined memory to be equal to max rows times size. So the preprocessor will take max rows and put 100 there. It will take size and put 50 there, and it does not calculate 5,000 to be memory. What will happen when it gets to a point where you say, like, for example, int m equals memory, it will replace memory with 100 times 50. It does not do arithmetic. So here we have an example. The header size is defined to be 20. The row size is defined to be the header size plus 30. So we're going to print out the max rows times row size. So the text replacement will work out to be 100 times 20 plus 30. Now what happens? Because it's a textual replacement, it's not following the C++ precedence rules. The text replacement becomes different. So because of the precedence, this will print out 2030. You're expecting, okay, max rows is 100. the row size is header size plus 30, and the header size is 20, so 20 plus 30 is 50. 50 times 100 should be 5,000, right? No, because when we do the text replacement, we have 100, which is max rows, times 20. Multiply comes first. So you've got 100 times 20, which is 2,000, plus 30. So keep that in mind. So the way you get around that is to use parentheses. See, when you have your memory in here, define it, put parentheses around it. And replace it, it will substitute, when you have memory, it will put in the parentheses. And so this will be 100 times 50 into parentheses. The parentheses in the replacement will be put into the replacement along with everything else. So you put parentheses around it like this. So when it comes down and gets replaced, it'll get replaced like that. Then you'll have 20 plus 30 is 50 times 100 is 5,000, which is the answer you were expecting. So when you're doing macros, if you're going to do something like this, instead of using the C++ language features, remember parentheses are extremely important. Now, one of the things that is not replaced in C++ is conditional compilation. So we're using the preprocessor to compile things based on the conditions of different things. So we have if-def, if-ndef, which is if not defined. This is saying, if the macro has been defined, then we do all this code. If the macro is not defined, then we do all this code. We can also have if, where we can make macro comparisons. Else, of course, so if this is defined, then we do all this stuff. If it's not defined, then do the else portion. And C++ does not have an else if keyword. The preprocessor does. So you can have if all this if this is true, do all this stuff. Else if this is true, then do all this stuff, and then else finally do this other stuff. So let's do a real quick example on that. You can say if max is defined as being greater than 20, then do some code, and then it's elif, not else if. Else if something else is greater than 30, then do some code, and you can have as many elifs as you need, whatever that is, and then finally have an else and have some code, and then end it with end if. So based on these conditions, one of these sections of code will be given to the compiler to compile. The others will be just dropped on the floor. Now you see include guards, and we just told you to use them basically, but here's how it works. We have if not defined, some include guard, and then if it's not defined, then it will compile the code and proceed. And the first thing in there is to define it. So now it's defined, and we can put in all our other defines, such as, for example, we're set pi equals is a really nice long number, and set its type to be double. And then we have the end if. So this is an example of an include file with proper include guards. So you can include this file in different compilation files from all over your code, because you need to have this particular constant. The second time it gets into the code, it will ask if this is not defined. Well, it was defined the first time, so it'll just throw all that code out. And what the advantages of that are, if you were just to put this header file and include it all over the place, because something is necessary for it to be included from different places, the second time it hits this definition, you'll get an error. The compiler or the linker or something in your process will say, hey, you tried to define this twice, I'm not going to let you do that. So you've got your include guards that prevent that from happening. So the second time that file gets included, so the code will not be processed. So you won't get an error for redefining pi. Now you might want to say, well, I'll just include it in one place. Well, you don't know which place is going to be compiled first necessarily. You may have something that is working, you need to recompile it, and it doesn't have it in there because it's there because they're compiled it someplace else. Well, no, it's not there because you compiled it someplace else. It was compiled on a completely different day. So instead, you just have your include guards. So when it gets included the second time, it's already there, no problem. So here's another typical example. So you want to have a test version of your application that's full of printouts. It says, I am here. I am in this function. I am in this method. I have been called. I've been called. These are the values of my parameters. Because you want to find out this code is not working. Why is it not working? But you don't want all these printouts coming all over the place when you deliver it to the customer. The customer will just assume that everything is working. They don't want to see a bunch of noise printing on their screen. So you have production defined, which can be defined above or it can be defined at compile time. So your code here, if this is not defined, then I've got my debug printout. And the else condition, of course, if it is defined, you should probably definitely put a comment on it so that you know what the else is for. Else it's not production. And then you want to print out just the regular, or you want to actually send that data to the production file. You don't want to send it to the production file while you're testing. So it's not production. You just want to print it out on your screen to see that everything is working. So the compiler will never see the testing code. One side or the other, the compiler will never see. It will either never see this or will never see that based on whether or not this macro has been defined. Now you can also put a value on there. You can say production equals 7. And then what you could do is say if production is greater than 5, for example, then process all this code, because you might have a beta tester. So it's in production, but we're still testing it. So you might say for this guy, your production is defined to be 4. So he still gets the data, but it's maybe not as much as the developer gets. And you can undef them. You can say, well, this particular section, we don't want to print for anybody, so we will undef the production macro. And then when we run into this code will be compiled because it's not defined, because we just undefined it. So the macros can also be defined on the command line when you compile the code, when the source file is compiled. That can be very useful. You can define all sorts of different things. You can say, if I'm on a Windows box that include this particular header, which has got all of the information we need to know about Windows, like, for example, if you're using the C drive or something like that. If we're on Linux, then we include this Linux stuff, which doesn't have anything about the C drive, because there's no C drive on Linux, et cetera, et cetera. So it's also good for a temporary removal. I use this type of feature all the time in my code. So you're testing some code, and you want to comment a section. I don't know what's going on. Let's see what happens if I take this block of code and remove it. Well, rather than physically removing it, because now it's gone. What did I do with it? Where did I put? Oh, instead of doing all that, you just put an if-def around it. Now you don't want to use a comment, because the single line comment, you have to go line by line by line and put the comment in. You might get to a line that's already got one on there. So later on, when you want to take it out, you have to remember to only take out the ones that you put in. And there might be hundreds of lines of code. You don't want to. It's too much trouble. You can't use this to go comment block, comment the other thing, because if the code was written right, there's already some comments in it, and there might be some comments of that type. And as soon as you get to the end comment, well, your commenting has also been ended by virtue of the extra end comment. Now, some compilers will actually nest these things, so you could actually do something like comment, comment, end comment, end comment. Other compilers won't do that. So as soon as you get to this one, this section is considered the comment, the rest of it's real code, and this extra end comment is an error. It depends on your compiler. But instead of worrying through all this stuff, we use if-def. So we put a code line up here, if-def, this var I know is not defined, because I make it a word that I know is not definitely going to be defined. So here's the code that I want to comment out to the code that the compiler will never see, and then put an end-if and put a comment on the end of that, and it says I put this here because I am debugging this code. So this whole section of code now will be removed. And you might even want to put an else in there, for example. So you want to put in your testing code. So all of this code in here is to define var 17. So I'll just put in the else in here while I'm testing. var 17 equals 7. Or whatever value I want to test with. So you can have thousands and thousands of lines of code trying to calculate var 17. I'll just put that into an else, just put in the answer that I think it ought to be, so I can test the code that comes afterwards. And then when you're through testing, you can put a define right in front of it, whatever that name is, and now suddenly it's defined. You switch back to real production code. Or you just go back and erase those particular lines that you were using to test with, which is a lot less hassle than worrying about comments. Now, one of the things, the dangerous features in using macros are functions. Macros have a facility for creating a small, but sometimes not quite so small, text function. So you actually define a function, like, for example, square. The classic one is define square, and then pass it x, and then it'll be x times x is the result. And so you just say square x, and that will be replaced with x times x, whatever x happens to be. So you could call that with square of 7 in your code, and the preprocessor will replace that with 7 times 7, which will translate into 49. So here we have macro with a parameter. You can have more than one parameter. You have x, comma, y, comma, z, whatever. And then a one-line definition. And it's very important to remember, it has to be one line. What if my code's too long for one line? Well, you have to quote the end of the line. Second line, and the last line has no backslash. That will all be treated as a single line. Make sure this is the absolute last character on the line, because if there's a space after it, you're quoting the space, not the new line. That will destroy your macro function. And there's no spaces in the macro definition, because the first place that you get to a space, the preprocessor says that's the end of my macro keyword, and the rest of it is the definition of the macro. So as long as you have no spaces here, no spaces there, no spaces there, you have parm1, parm2, no spaces, then you've got your macro function. And the backslash must be the very last character at the end of the line, because that escapes the new line, so that all these lines will be treated as if it was one long line. So here's an example. And we put in the parentheses to prevent it from getting precedence issues. So we're defining the area of a circle. We've defined it area circ r. And pi has been defined someplace else. And so it's pi r squared. Rather than calling the square function, we'll just do r times r, which gives us the square of r. And we have volume of the cylinder, where I have the slash, not because I need to, but just to illustrate the slash. So we have the volume of the cylinder with two parameters. We have the radius of the circle at the bottom of the cylinder, and the height, which is how tall the cylinder is. And the volume happens to be the area of the circle. We're passing it the radius, multiplied by the height of the cylinder. So we've got this replacement, which will go into here, and then all this replacement, which will go into there. And again, remember the parentheses are there, and they're there for a reason. This is a text substitution. It doesn't do any number crunching. So what happens if you leave the parentheses out? Let's illustrate that. Let's say you have area circle is pi times r times r. So we say float A1 is 3.0. Well, I want to have a circle that's a little bit larger than A1, so I pass in A1 times 5.0. The A1 plus 5.0 is the text that will be passed. It's not going to take this and do some arithmetic and work out that this should be 8.0 and then pass that into the macro. No, it takes the text, A1 plus 5.0, and passes that into the function. So in this case, what we'll get is 3.1415, which was defined up above, multiplied by A1 plus 5, multiplied by A1 plus 5. Now there's no parentheses, which means it will do the multiplication first. And you're going to be looking at the answer and say, wait a minute, how could that possibly be the right answer? It's not the right answer because you didn't include parentheses. But if you put the parentheses in there, then you'll get the parentheses. R will be replaced with the text, and it will do the addition first the way it's supposed to, and you'll get the answer that you're expecting to get. Now, you can avoid those problems by not using them. I'm presenting them here because you are going to see them, and you're going to have to need to know how to work with them in order to figure out, I got a bug that's going on, and oh, here's a macro, and so I have to look at what this macro is being defined, and you might say, oh, I see what the problem is. The guy should have put parentheses around that. You can see it was used for performance, like much of the way an inline function can be used. You'd have some quick and dirty calculation, and you didn't want to retype it over and over and over again, and it gets used each time. And so you put it inside of a macro. You only had to type the macro, and the macro would get replaced and get expanded out, and the compiler would work, and everything was wonderful. You didn't have to have a function call where it goes, jumps to the function, does the stuff, then jumps back. And so it gives you a little bit of performance improvement. In C++, you can use an inline function instead, which gives you the type compatibility. You don't have to worry about the parentheses as much. So when you pass it a parameter of A1 plus 5.0, the C++ compiler will actually evaluate that for you to a number and pass that to the function. So, and plus the compiler can do type checking, so you can't pass it something that's not, like you make a typo, you put in A2. The compiler will say, I don't know what A2 is, you didn't define it. If you use a macro, the macro could be defined pages and pages and pages ago, and you put in A2, the compiler, the preprocessor will happily put the A2 in, and it could put it in several places where you happen to use it. And so now the compiler has got several places to say, well, I don't know what A2 is, instead of just the one place where you made the mistake. So it avoids, there's several other problems with macros that where if you don't define your function a certain way, certain problems can happen. There's things where I want to do a little bit of code, and I'll put that like inside of a while loop or something. So that what happens if the macro gets called inside of an else statement? And with an else statement, you have to have a semicolon before it. What if you put it after the else statement and the semicolon's in the wrong place? All kinds of issues we come across with running macros to do a function. All of those issues just evaporate into the wind if you use a function call or an inline function, because they're very, very hard to debug those types of problems. So the bottom line is you probably should, I can't think of any good reason to use those, except to know that they're there, because people do use them, so you're going to run into them. You're going to have to deal with it. Now, there's occasions when you need to mix C with C++. I mean, there's tons and tons of C code that's out there. It's working. It's been tested. It's been put into production. People are using the products. And so rather than just throwing it all out and rewriting it, just grab those subroutines and incorporate them into your C++ code. But you got a problem. C code cannot be linked with C++ code because of the internal naming. C++ adds different names to the name because the name can be polymorphed. You can have F with an integer parameter. You can have F with two integer parameters. You can have F with a float parameter. So C++ will mangle this name in some kind of internal way so that it can internally tell these three disparate functions apart. C doesn't do that. When you define F as a function name, it puts into the simple table for the linker the name F, and that's it. So if you want to bring that code into C++, you need to use the extern C construct. So you can either do, if it's been well designed and well written, there'll be a header file with all your definitions. So you can just say if def. Well, no, you erase all this. So what we've got here, if you can read, a lot of systems, particularly like Solaris and Linux, where they know that they're designing the stuff to be used with either C or C++, they'll put this in the header file. If this is two underscores, by the way, underscore C++, then we'll have extern C inside of double quotes, open brace, and an end if. So then the legacy C code that'll be compiled or included into your code, and then the same thing to close off that brace. Now what you can do in your C++ code, if you're including some C header file, you can just do the extern all by itself, and then include, which actually needs to be at the beginning of the line. So let's do that right. And then whatever your C header file is, and then end it. And so now you've got the C header file. This tells the C++ compiler, don't mangle the function names. Just put them in straight the way C does it. And that way you'll be able to successfully link your C code with your C++ code. Now there's a few macros that should be predefined with every standard compliant compiler. And these again are these are two underscores which got bolded and blended together here, but they didn't here. So you've got the current line in the source file, so you can print that out like we have it here. We're printing out, the program is in this file, and so the name of the file will print out in your output. You got a string literal containing the name of the file, the date that the file was compiled, the time it was compiled, and as we mentioned earlier, we have the underscore C++ that says this is a C++ compiler as opposed to a C compiler. And it depends on, most of the time you don't care what it's set to, you just want to know that it's set, but it is set to something equal to or greater to this long value, 1997 November. And so each compiler can add something to that to have a unique identifier that says, I am compiler this number. You can print it out and see what value comes up based on what compiler you're using. Now there's ways of misusing. There are many you can misuse anyway. This is one particular thing you can misuse, which I used to think was cute until after you get into the community, you deal with other programmers for a while, you find out this is not cute. It will actually piss off people who are looking at your code. No, don't do that. So people think they're using cute. It makes the code confusing for other people. What we're doing is we're trying to make this look like a different language, in particular Pascal, by saying we have if open percent, and then is the close percent begin end. So you make code like this, the macro will turn that into if, open parentheses, A greater than B, because the capital if gets turned into that, the then gets turned into this, the begin turns into the percent, and then you have the C equals A, and then you have the end turns into that. So it takes something that's a crappy sort of Pascal, sort of ALGOL looking language with capital letters, and turns it into C. If you want to work in Pascal, there are Pascal compilers out there. If you want to work in ALGOL, there are ALGOL compilers out there. If you're going to be working in C and C++, work in C and C++. So don't do things like that. Please don't do things like that. Now, we've been letting the IDE do all the work. Sometimes your work environment isn't so blessed as to have an IDE that does all the work for you. And even when you're working with the IDE, you need to tweak a few things by adding switches and options and things. So to give you an idea, this is what your pretty typical way of, on the command line, compiling your program. So you have a program, prog.c, you have another program, other prog.c, and you want to compile it into a binary executable called prog. So prog will be the executable, and your switch will be -O that says my next argument is the output that I want. You can also do this one unit at a time with the -C option that says take this file and don't turn it into an executable, turn it into an object file that can be linked to other object files. And then once you've done that, you can link into your output file your object files that were compiled from your other C sources. And of course, this would be C++ if this was a C++ file, or capital C, which is not a good idea in Windows, but I don't have much room here, so I'll make this a capital C just for fun. I have seen places where they will name the C++ source files with a lowercase c. I don't recommend that. It causes all kinds of heartburn down the line, but it's out there. There's nothing to do about it except use it. So this is the way everything works for your normal compiles. All your libraries, all your include files are where they expect to be. But sometimes I need to link into the Oracle database library so I can call Oracle and go back and forth to the database, or to MySQL, or I need to link into the X Windows GUI API so that I can paint Windows. And you need to know where all that is, or rather the compiler needs to know where all that is. So you need to put a flag -I so that it knows where to find include files. And you have -L so that is capital L, so that it knows where to find the object files and library files, and lowercase l to specify which specific library or object file you want to incorporate into your code. So here we have an example we want to get to on the Linux platform, the MySQL database, because we're making an application that uses MySQL to save all of our data in a persistent manner so we can get things into the database, get things out of the database. So in this case, myprog.c is using include files. Along with the standard location, it will be in user include MySQL, because the MySQL happened to be installed in such a way as to install its header files for your use in that particular directory. And so you would compile it with the -I, so that when inside your C++ code, you'll have include mysql.h, and it will look in all of the standard locations, and it will look here until it finds that include file, and then it will include those definitions and constants and function prototypes into your code. And then the capital L, it also needs to link to the MySQL binaries, to the library, so that it can call those particular functions that MySQL has defined for your use. And in particular, I'm writing a client application as opposed to some other application, so I need to get that particular library file, include and link it into my application. So the application uses functions. Now there'll be a library called, and this is the convention, which may or may not make any sense, but it's been around for a long, long time. It's the way they do it. There's lib, then the name you specified, and then .a. .a means it's a library which will be included directly into your program. It could also be .so, which makes it a shared object, which you'll be getting links to located into your executable, but it won't actually bring in the library until runtime. So here we have dash lowercase l MySQL client. So the file it will be found is lib MySQL client.a, and it should be located in user lib64 MySQL. Obviously, this is on a 64-bit machine. If you're on a 32-bit machine, you would not have the 64 there. So this is a platform dependent, but every platform has something very similar. So it depends on how your platform gets compiled. So you get everything running on your Linux system. So when we want to make this run on Windows also, you change the compile line, how the code gets compiled to bring in, it would probably be something like C:/MySQL, wherever it happens to get placed on the Windows system. And that would be on your command line for compiling your application. Now you can also compile all of your stuff into an object file. You can bring all your object files and put them together into a library that can be published that other people can use, but that's beyond the scope of this class, because one thing is very platform dependent. It depends on whether you're running Solaris or Sun OS, which is different than Solaris, even though they're from the same company, or Linux with Red Hat Linux, Ubuntu Linux, Windows, Apple. So every system's got a slightly different way of putting your objects together into a library, but it's fairly straightforward. You can look that up on Google and find out how to do it if that's what you want to do for your particular application. And there's some other useful flags you can put on the command line. Now, we've already seen some of these. -C creates an object file from the source file, and that's all it does. It's just one step of the compilation process. Actually, it's two steps because it does pre-processing. -G is to add internal code to the object file, which will get linked into the application, which allows a runtime debugger to hook into your code. Even while it's running, you can have a program that's running in the background. You grab your debugger and hook into that process to actually find out what that process is doing. You can list the source. You can put in breakpoints. This is when you reach this point, stop. And you can look at it as what is the value, internal value of this variable, and take a look at all sorts of things. It's very useful for doing runtime debugging of your code. You can add a -D and some macro name, which will set a macro. It's just like doing define and then whatever your macro is in your source code, but you're doing it on the compile line. So if you don't want it set, you don't put it on your compile line. So you have code in your code that says, if this macro is defined, then compile all this code up until you get to the end if. So you can also define it to a value. So you can have things like, you can say if version, your version, for example, is greater than 2, then compile all this code. So you can put on here, define your version is 1, which means all this code will not get compiled, because this is only for code for version 2 and greater. You can put the -E will stop after pre-processing. It will take the code and it will pre-process it just like it's getting ready to pass it on to the compiler, but instead of passing it to the compiler, it will print it all out. So you can take a look at it, and it's great for debugging your macro bugs, but you shouldn't have macro bugs because you should not be using the macro function, just in case you are, or you're just curious to see what the output looks like. You can do this and take a look at what the output looks like. -S will stop after compilation, and it will produce assembly language code instead of object code. So if you're familiar with assembly language, you can actually take a look at the assembly language code to see what kind of code the compiler is producing for you. Like I say, that's if you know assembly language, and not very many people know assembly language anymore. Now, if you're compiling from the command line, you just put those flags on the command line. What if you're using Eclipse? Now, I'm not going to cover all the other IDEs that are out there, because I particularly don't use them, and that's not really part of the class anyway. But I'm just going to, for convenience sake, with how you get into it in Eclipse. You open your project, go to the project menu, select Properties. You have C++ Build, and go to Settings. You'll find all kinds of different settings. What you're looking for are the preprocessor settings. So select Preprocessor. There'll be a little add icon with a plus sign. Click that. And then they will say, enter macro for -D. So you just put in whatever you want, like version equals 5, for example, production, test, whatever you need to put in there. And in this example, we have version equals 5. So if you have this type of code in your source, this will be compiled into your source. If you put some other value there, then it depends on what you put. And now we'll get to define a mutable preprocessor macro constant on the command line. And no, you can't quite do that. But that's it for today's class in C++ from educator.com. We'll see you at the next class.